Right, here we're going to just kind of refresh a little bit with dimensional analysis, also with an analogy that will help lead us into the mole. So let's say that you buy 3.5 dozen roses and want to know how many roses you have. So I'm pretty sure a lot of us can do this in our head. However, let's show it with dimensional analysis to kind of help segue into the next problem. So if we have 3.5 dozen roses, and we want to know number of roses, like individual roses. It's a Friday afternoon and I'm very tired. Okay, we need to first figure out what the relationship between a dozen roses and 12 roses is. Okay, so we know that 1 dozen roses is equal to 12 individual roses. And we can write this equality as a conversion factor to be used in dimensional analysis. So we can say that 1 dozen roses over 12 roses is equal to 1, so this can be used as a conversion factor. Or 12 roses divided by 1 dozen roses. And that would also be equal to 1. Okay. To begin, again, we were given a certain number of dozen roses and we are asked to find the number of individual roses. So let's go ahead and start with what we know. So we've got 3.5 dozen roses. And try to set up dimensional analysis to where I can get out of dozen of roses into my desired unit. Okay? So I'm left with these two conversion factors, and I can figure out which one is going to cancel out my dozen roses, meaning I need my dozen roses in my denominator. Okay, so this one is going to be our desired. So we'll say 1 dozen roses, and put 12 roses on top. Dozen roses cancel, we're left with just regular old roses, and I'm sure that a lot of people could have figured out that you would multiply 3.5 times 12. Let me grab my calculator real quick, just to show you, because if these were bigger numbers, definitely would want your calculator, and let's just practice plugging in numbers when you have dimensional analysis. So since these are both in the numerator, I can multiply them. My denominator is understood 1 here, times 1, so just 1. So I'm going to do 3.5 times 12, and 42 is my answer. So if I have 3.5 dozen roses, I've got 42 individual roses. Okay, so our unit is different, the magnitude of the number is different, so 3.5 versus 42, however the total amount is still the same. And that's the whole point in dimensional analysis. One really big reason why I chose to do something that we all know, dealing with a dozen, is that it doesn't matter if I'm dealing with roses or Ferraris, it's still going to be that same like 12-to-1 ratio. And that's because a dozen means the number 12. So when we lead this into the mole, which you'll see in the next example, you'll realize that it's a very, very similar situation when you're going from the kind of counting unit, like of dozen, to the number of individual. So that's what we're going to start with, is going from moles to individual particles. So tune in.